I'm going to show you how to calculate the percent composition of an element within a compound. I'm going to give you a couple of examples, show you how to calculate them, and then ask you to do one on your own. The first compound we're going to be working with is going to be, let's use lithium chloride. So within lithium chloride, it's clear that you have one lithium and one chlorine atom. What you're going to do first is go to the periodic table and find the mass of each of those elements. So lithium has a mass of 6.94 grams, and chlorine has a mass of 35.45. Okay. The first thing you need to do is add them together. And get a total. Please don't round these numbers. Write whatever number it gives you. If you look on your periodic table, almost all of these, actually I think all of them, yes, all of these elements go 2 places past the decimal. Therefore, you need to keep your answer 2 places past the decimal. Okay, so now we have a total mass of lithium chloride. This total mass is called the molar mass. The molar mass is how many grams of a compound are equal to 1 mole. We talked about the mole last semester. We're going to be bringing that back. The mole is a conversion factor, and in order to convert from grams to moles, you would need the molar mass of a compound, and the units on that are grams divided by the moles. Okay, so that's just a quick little side note. So back to calculating percent composition, you need to have the individual masses and the total mass of the compound. The next step is to just divide the individual mass by the total. Because lithium is smaller, it is naturally going to be a lower percent composition of the compound than chlorine, because chlorine has a larger mass. So in your calculator, you take 6.94, which is the mass of 1 lithium, and divide it by the total mass of the compound. And I get the number 0.16. Again, 2 places past the decimal is fine here. This is not a percentage, so I need to take that answer and I need to multiply by 100 to get it into a percentage. So times 100 is going to get me 16%. Do the same thing for chlorine, 35.45 divided by the total mass, and then multiply by 100 is going to get me roughly 84%. This has to add up to 100, so you notice I rounded 83.6 up to 84, and that's because my first percentage is a whole number as well and does not go past the decimal. Therefore, these cumulatively add up to 100%. So if they add up to 100%, you know you did it right. Okay, let's do a compound that's a little bit more complicated. Let's say that I have, let's use sodium phosphate. All right, so sodium phosphate, you notice that it has 3 sodiums, 1 phosphorus, and 4 oxygens. So the first thing I need to do is list the elements that I have. I have sodium, phosphorus, and oxygen. Sodium's mass is 22.99, and there are 3 of them, so I need to multiply that number by 3. Phosphorus has a mass of 30.97, And because there's only one of them, I'm not going to multiply it by anything. Just for the sake of consistency, I'll just put times 1. And then oxygen, there's 4 of them. And the mass of oxygen, 16.00. And there are 4 of them, so times 4. Okay. So in my calculator, the first thing I need to do now that I have these values is find the total mass of this whole compound. So I'm going to take 22.99 times 3, add that to 30.97, which is the mass of the phosphorus, and then add that to my oxygens, which is 16 times 4. I get a total of 163.94. And again, this is the molar mass. It's how many grams are in 1 mole of a compound. Okay. Put that up there as well, the units. All right, so now that I have my total mass, I need to divide each of these. So this right here equals 68.97. 22.99 times 3 is 68.97. This is what it is. And then 16 times 4 is going to be 64. Okay, so that's the total mass of each of them. I'm going to divide that by the total mass of the compound. And then I need to multiply that by 100 to get it into a percentage. Okay, so my first step, 68.97 divided by the total mass, 163.94, and then times 100. Round that to 42%. 30.97 divided by 163.94 times 100. 19% makes sense because phosphorus, there's only one of them. It has the smallest mass. I don't know if you can, there we go. We'll round that up to 19%. And then the last one is my oxygen, 64 divided by 163.94, and then multiply by 100. It's going to be 39%. So then just a quick check, I'm going to take my numbers, 39, make sure I rounded correctly, add them up, and they all total 100%. So I know I did it correctly, and I know that I rounded them correctly. And that's it. So what I'm going to have you do is calculate one on your own. So please come to class tomorrow with this problem completed. Calculate the percent composition of this molecule. It has 6 carbons, 12 hydrogens, 6 oxygens. This is a glucose molecule. Please come to class with the percent composition of these 3 elements within this compound.